the second problem. Okay, the second problem is now all set up. And as with the previous program, the first thing you want to do is to take a look at the C version, and then you say, okay, do I understand what the C version is actually doing? The C version is right here. I renamed the C version with an underscore and a C just so that the linker will not complain that I have two labels, called fib. Okay, if n equals to 0, return 0. If n equals 1, return 1. Otherwise, return the Fibonacci of n minus 1 and the Fibonacci of n minus 2. Okay? Is that okay so far, with the C code? It's fairly typical recursion. You check, when to stop, and if you're not stopping, then you call the subroutine again. Except in this case, we have a double recursion, not double recursion, but 2 points to call back the same function. So if you're not really sure that you know what this is supposed to do or what value are supposed to be returning, you can actually just change the C program to refer to the C version of the function and test it first. Okay, so you change the program, you say make, and then you say okay.
So are you always going to have it set up to point to the assembly function?
Sorry?
Are you always going to have it set up to run the assembly function?
Yes. But this time, because the assembly the assembly version also has other problems, so we have to exclude it from the make file first, so it doesn't. Oh.
Cause problems.
Yeah, I have to say make main because the default target is incorrect. Undefined reference to fib. Okay, where? No, it's the recursion itself. There we go. Make again. Oh, make main. Dot slash main. We can put a 5. It will say the Fibonacci of 5 is 5. Okay. Okay. So that gives you an idea of what type of value it is supposed to return for whatever argument you're passing to main. Is that okay?
How
Okay.
about if, no, never mind.
So the problem of a minor problem is because I put this target ahead of the executable, so that becomes the default target. So if I swap it, then it won't make the tar file the default target anymore. Okay. So are we good with the C version? Okay. So now we want to yeah, go ahead.
On the final, we're not going to have to mess with the main file, right?
In this case, we actually did not have to mess with it, except it was not the default target. So in the actual exam, if you say make main, it will always make the executable main. So you just have to be more specific if you want to be sure.
I believe the questions are: can we assume the make file to be good?
Yes.
Yes. Okay.
Yeah. All right. So now that we have this, we can now take a look at the assembly version of fib. Yep.
What was the command to make all the timestamps the same?
Touch.
Touch.
Touch pointer?
Well,
Touch
touch
Yes,
star.
Touch space.
Touch space asterisk.
Professor,
Yep.
do you think it would be better if you gave us some parameters in the results instead of us trying to figure out if, for example, if we wanted to run the C code to see what the results would be for any parameters?
I could do that. So if you run this, it's supposed to give you a feedback like that, something along that line.
Because it may not be so intuitive to change it back to the C version. I don't know, it's up to you.
Okay.
Just a thought.
I can do that. So we have the Fibonacci subroutine here, and we want to figure out whether it's doing it correctly or not, and if it is not, what is being done incorrectly. So the first thing we want to check is to see whether the parameters are all set up correctly. OEBP is 0, that's good. Return address is OEBP plus 4, that's good. N is OEBP plus 4, that's not good.
Return adder.
So it is return address plus 4. Okay, that's our parameter n. And then we take a snapshot of the stack pointer, which becomes the frame pointer, and then we save the frame pointer. That's opposite, right? You have to save it before you change it. So flip that, which usually means you want to take a look at the end and make sure that that one is also, not, incorrect. Okay, so now we go back to the beginning here. Okay, here we have the comparison. We want to compare n to 0. If it is not 0, we jump to the non-zero function, label. If it is 0, we put a 0 into EAX and go to NIF. And NIF is down here right before we return. Would that be the right thing to do?
No, no. If it's not 0, you need to jump into the function.
No, if it is not 0, you have to check whether it is 1 or not.
Right.
Yeah, but isn't that what we are doing here with not 0?
Compare. It's not 0. Oh, okay.
Okay, let's split the screen and then bring up main.c.
But you want to jump to
So here's the C version,
Yeah.
and here is the assembly version.
Okay, return 0, yes.
So,
But you didn't move it to EA, yeah, you did
I
move
did.
0 to EAX, so
Yeah.
yes.
Jump and in.
jump to
And there you're
NIF.
just jumping to get out.
That
Yeah.
looks
Yes,
good.
that's right.
That looks good. Okay, so that's good. Okay. So when it is non-zero, which means, here, starting from here, am I doing it correctly?
Right.
Compare 1 to the parameter n. If it is not equal to n, we go to not 1. If it is 1, we specify the return value to be 1 and then jump to NIF. Is that looking right to you?
Yeah.
Okay. And then we have some code here that has no label in front of it.
Which
I wonder.
you're not a not 1,
Okay, so that would be label
not
No.
1.
not 1. Okay, very good. Okay, so if it is not 1, then we have to implement this code here. How do we implement that code? Now we know that we have to call fib twice, right? Because we have fib called here, and then we have fib called here as well. So the question is, am I pushing the right parameter on the stack? I'm trying to push n minus 1 on the stack, but is that how I push n minus 1 on the stack?
I would push n.
What would this do? What is this actually going to do? N is the displacement, right? N is the displacement from where EBP points to the first byte of parameter n. So this is going to change it to push the bytes, but they'll be off by 1 byte.
Yeah.
Okay, so this is not what we want to do.
I take the -1 out.
Okay, so we can take the -1 out like that, and then we can say subtract 1 from
EBP.
no,
No, that's the same problem.
from where ESP points to, because whatever you push here will be pointed to by ESP. So what you can do is to subtract 1 from exactly what you just pushed on the stack, and that. So after these two instructions, whatever is on the stack will be n minus 1. Is that making any sense? Okay. So there are several ways to get this done. This is just one way to do it. We call fib, we add 4 to ESP. In other words, we undo the parameter that we push on the stack, and then we push EAX, which is the return value, on the stack. Well, we don't know whether it's right or wrong or not. Okay, at this point we'll just kind of say, okay, we'll just let it sit for a while. Okay. And if you want to, we can say, save the value of fib n minus 1 on the stack, because that's what it's doing.